Hello friends. So today our topic is probability, and under this topic we will study these 2 points: exhaustive events and mutually exclusive event. So first we will be studying exhaustive event, and for this topic we will be understanding with some examples and some relevant questions. So let's discuss. So first I will be discussing with you the definition of exhaustive event. A set of event is exhaustive if the events cover all the possible outcomes. Let's take an example. Imagine rolling a die. So when we roll a die, so there are 6 possible outcomes. It could be 1, 2, 3, 4, 5 or 6. So I take 3 events: event A, event B and event C. So event A is getting an even number, and event B is getting an odd number, and event C is getting a factor of 30. So if I'm talking about getting an even number, so if we roll a die, so there are 3 even numbers: 2, 4 and 6. So let's shade those numbers. So this is 2, 4 and 6. Now event B is getting an odd number. So odd number are 1, 3 and 5. So 1, 3 and 5. Now third is event C, which is getting a factor of 30. So factor of 30 are 1, 2, 3, 5 and 6. So these 3 events are given, and we have to check whether these are exhaustive event or not. So first I will check whether I have shaded the right column or not. So these all are right boxes that we have shaded. Now, are events A and B exhaustive or not? So as per the definition, if the event cover all the possible outcomes, see, in A, the 2 is covered and 4 is covered and 6 is covered. This 1 is not there, 3 is not there and 5 is not there. I am talking about A and B. So the remaining boxes, like 1 is not covered in A, but that is covered in B. Alright. Now 2 is not being covered in B, but that is already covered in A. And this 3 is covered and here 5 is covered. Now you will check whether all the 6 possible outcomes are covered or not. If all the 6 outcomes are covered, then A and B are called exhaustive event. So let's check. We are checking in A and B. So 1 is not covered here, but 1 is covered by B, and 2 is covered here, 3 is covered here, 4 is covered, 5 is covered and 6 is covered. So that means A and B are exhaustive events. Between them, A and B include every outcome from 1 to 6 that we have already checked. 1 is covered by B and 2 is covered by A, 3 is covered by B and 4 is covered by A, and 5 is covered by B and 6 is covered by A. So that means all the 6 outcomes are covered. So that's why A and B are exhaustive events. Now I will be checking whether A and C are exhaustive or not. A and C. So let's check. So 1 is not covered by A, but that is covered by B. Alright, now see, the 2 is covered by A and C both. Alright, now here the 3 is not covered by A, but that is 3 is covered by C. Here 4 is covered by A but not by C, and it is covered by both. Yes, now A and C include all the outcomes between them, so it doesn't matter 2 and 6 occur in both. Alright, that must be at least at one place. So now we will check whether all the possible outcomes are covered or not. See, 1 is covered between A and C, 2 is covered, 3 is covered, 4 is covered by either A or C, 5 is covered and 6 is covered. So that means A and C are exhaustive events. Now I will check for B and C. So if I am talking about B and C, now 1 is covered, 2 is covered, 3 is covered. Now we will see the number 4, which is not covered neither by B nor by C. This both the columns are vacant. So that means B and C are not exhaustive event. The outcome 4 is not included in either event. Now, exclusive, mutually exclusive event. So the definition is not like very difficult definition. It's a very easy one. If there is no overlap between them, like if two events are given and if they're not overlapping each other, then they're called mutually exclusive event. Let's take an example. Two events are mutually exclusive if there is no overlap between them. So here are the events from page 1 together with a fourth event getting a 6. Getting an even number 2, 4 and 6. Getting an odd number 1, 3 and 5. And getting a factor of 30, 1, 2, 3 and 5, 6. Getting a 6, that is 6 only. So are events A and B mutually exclusive or not? A and B. Now I will check whether they are overlapping each other or not. So this is A and this is B, no overlap. Here also no overlap, no overlap, no overlap and no overlap, and here as well no overlap. So none of the outcomes are same. Now I will check, are events B and D mutually exclusive or not? B and D. See, B and D, B and D, B and D and B and D. So none of the outcomes are same. So it doesn't matter that outcomes 2 and 4 are not included. So that means these are mutually exclusive. Means the event that should not be repeated in both the events. Are events A and C mutually exclusive? Let's check. In A and C, we can see this 2 is coming in A as well as C. Similarly, this 6 is coming in A and as well as in C. That means here we are getting overlap. So that means the events A and B are not mutually exclusive events. Now let's do some questions. What is the probability of getting either an odd number or 6? So the probability that comes out to be 2 upon 3. Let's check how this happened. So if I'm talking about either an odd number or 6, so odd numbers are 1, 3, 5, and 6 is itself 6. So that way, how many numbers do we have? 1, 2, 3, and 4. So 4 upon total number of outcomes, which is 6. So 4 upon 6, that gives you 2 by 3. So now let's discuss this question again by some different method. A dice is rolled. What is the probability of getting either an odd number or 6? So as we have already discussed, the answer was 2 by 3. So now work out how we get this 2 by 3. So either an odd number. So odd number are 1, 3, and 5. So that way we have 3 odd numbers. So 3 upon total number of outcomes. So that is 1 by 2. So I am writing here 1 by 2. Now getting a 6. So we have only 1 6 in a die. So the possible outcomes or outcomes, that is 1, and the total number of outcomes is 6. So I write 1 over here and 6. So what do you notice? The probability of getting an odd number or a just 6 is just the sum of the separate probabilities. Just the sum of probability, like 1 upon 2 plus 1 upon 6, that gives you 2 upon 3. So if events A and B are mutually exclusive, then P, so that rule is called OR rule. So P probability of A or B, that is equal to PA plus PB. That means the sum of the separate probability. What we did in the last question, the probability of getting an odd number plus probability of getting a 6. That way 1 upon 2 plus 1 upon 6, that gives 2 upon 3. So the symbol for OR is union. If that is mutually exclusive event, so that is equal to the sum of both the probability. So PA union B is equal to PA plus PB. Let's take one more example. If events A and B are mutually exclusive, so PA or PB is equal to PA plus PB, and that is to be denoted by union. This OR is to be denoted by union. So the probability of a traffic light being green is 0.5, and the probability of it being amber is 0.1. So as we know, they're not overlapping each other, because green and the amber, they are different from each other. So this way these two events are mutually exclusive. So what is the probability of it being green or amber? So what I'm supposed to do, just add both the probabilities. So that is G or A is equal to P of G plus probability of A. So 0.5 plus 0.1 is equal to 0.6. Thank you. Have a nice day.